Now let's take a look at taking derivatives of composite functions. The first one we're going to learn is the chain rule formula. Recall that a composite function is when you nest a function into another function, such as f of g of x. Chain rule is used on composite functions. So if you're asked to take the derivative of a function within a function, you would take the derivative of the outside function first, leaving the inside function the same, and then multiplying by the derivative of the inside function. So again, this means we take the derivative of the outside and then multiply by the derivative of the inside. Let's take a look at the 4 parts of example A, where we're asked to find the first derivatives of the following composite functions. Now, in this first function, we have a binomial in parentheses, 3x squared plus 5, and then that binomial is taken to the 4th power. Now, we can also call this chain rule formula the general power rule. 3x squared plus 5 is the inside function. So let's deal with that 4 first. So the first derivative would be the derivative of that outside function, the power of 4. So we multiply the front by 4, leaving the 3x squared plus 5 the same. Subtract 1 from the exponent, get 3. Now we have to multiply by the derivative of that inside function that's highlighted in yellow. The 3x squared, that derivative would be 6x to the first, and the derivative of 5 is 0. So when we simplify this, if we multiply the 4 by the 6x, we would get 24x times 3x squared plus 5 to the third. There is nothing that can be reduced or simplified here, so leave the binomial cubed as is. Now, in example 2, f of x equals the cubed root of the quantity 4x minus 1 squared. You might find it helpful to rewrite that using a fraction exponent. 4x minus 1 squared, and that squared would be divided by 3. So it's now to the 2/3. So to find the derivative, we multiply the front by the exponent of 2/3, leaving the inside the same, subtracting 1 from that exponent, and then multiplying by the derivative of the inside function, which would just be 4. So when we simplify this, we would multiply the 2/3 by this outside 4, giving us 8/3 times 4x minus 1 to the negative 1/3. We can rewrite this as the first derivative of x equaling 8 over 3 times the cubed root of 4x minus 1. So on part 3, we actually have composition functions being multiplied. So a big hint, we must use the product rule first. If you've forgotten what the product rule is, that means when we are multiplying two functions and we want to take the derivative, then we would take the derivative of the first function times the second function as it is, plus the first function as it is times the derivative of the second function. So we can consider these two binomials as those two different functions. So this one is f, and this one would be g. So let's take a look at the derivative. So the first derivative, we have to take the derivative of f first. So that would be 4 times the 8x minus 2, subtract 1 from the exponent, which is 3. But again, this is a composite function, so we need to take the derivative now of the inside, which would be just 8, and then multiply that by the g function as it is, 3x plus 1 quantity squared. So again, this is our f prime, this is our g. Now we're going to leave f function as it is. That's the 8x minus 2 to the fourth. So that's just the f function. Now times g prime. So looking at g, we multiply the front by 2, leaving the 3x plus 1 the same. Subtract 1 from the exponent, we get 1. But again, it's also a composite function, so we need to multiply it by the derivative of the inside, which would just be 3. So there's g prime. So again, we did the product rule and the chain rule. Now we got to simplify it. So in this first one, we're going to multiply the 4 and the 8. That's going to give us a 32 times the 8x minus 2 cubed times the 3x plus 1 squared, plus, in the second one, we're going to multiply the 2 and the 3. 6 times 8x minus 2 to the fourth times 3x plus 1. Now, as far as I'm concerned, you can stop here, but you might be asked to simplify further. So that means we need to factor out any GCFs. We have this first section before that plus sign, and we have this second section after the plus sign. Let's factor out each of their GCFs. So in this first one, we have a 32 and a 6. Their GCF is a 2. So factoring out that 2 from that first 32, that leaves us with 16. Factoring out a 2 from that 6, that leaves us with a 3. Now let's look at this next factor in common, the 8x minus 2. In the first one, they have 3 of those. In the pink one there, they have 4 of those. So we can only take out 3. So in the first grouping, we took out all of them, so there's no more. But in the pink grouping, there was 4, and we took out 3, so that means there's 1 left, 8x minus 2. And then last but not least, we have the 3x plus 1's in common. There's 2 in the first one, but only 1 in the second one, so we can only take out 1, 3x plus 1, which means we're left with one of them in the first group, in the yellow, but none in the second group. Believe it or not, we are not finished. Let's simplify what's on the right-hand side there, and we are left with 2 times the binomial x squared minus 2 cubed times the binomial 3x plus 1 times the binomial 72x plus 10. Number 4, we have a quotient. G of x equals 7x minus 2 divided by x plus 1 quantity squared. There are 2 ways we can do this. We could rewrite it as 7x minus 2 times x plus 1 to the negative 2 and use the product rule like we did in the third example there. But let's use the quotient rule this time, just so we have that as an example. So let's remember the quotient rule is if you're taking the derivative of a rational function where the top is the high part and we'll say the low part, and the derivative is the low times the derivative of the high minus the high function times the derivative of the low function all over the low times the low, or the low squared. So low d high minus high d low over low. So let's take a look at g. So g prime over x would be the bottom function of x plus 1 squared as is, times the derivative of the top function, which would be 7, minus the top function, 7x minus 2, times the derivative of the bottom function, 2, times x plus 1 to the first, times the derivative of the inside. But again, that derivative of the inside is just 1. All of that divided by the bottom function squared. So x plus 1 squared, quantity is going to be squared again. Now, just so you know, this part here, that's the calculus part. Everything from here on, that's algebra. We're simplifying. So we take g prime of x. Let's see what we can do to simplify the top. We're going to put that coefficient of 7 in the front of x plus 1 quantity squared minus still the quantity 7x minus 2. Here we've got the 1, but the 1 times 2 is just 2. If we distribute, we get 2x plus 2 all over the binomial x plus 1 to the fourth. Remember our exponent rules. Now let's keep going. After a bunch of algebra, we're left with negative 7x squared plus 4x plus 11, that entire quantity divided by the quantity x plus 1 to the fourth. Now, the reason we simplified and did all that is it's possible that that top could have been factored and reduced with the denominator. Couple of things to remember. As long as we have this subtraction, say over here, we cannot reduce the x plus 1 factors. Okay, only if everything's being multiplied or divided can we divide out. And also, we have to subtract everybody in this second portion here, which means distributing that negative. Those are some of the common errors that we have.